In this lesson, we will talk about logical operators. Logical operators are used in order to compose a new relational expression from two or more relational expressions. If you remember, when we talk about relational expression, a relational expression is composed of operands and one of the relational operators in the middle. But sometimes we have more than a relational expression and we want to compose a new one. Anyway, logical operators, we have three logical operators. We have AND, which is represented by this symbol. We have OR, which is represented by this symbol, and we have NOT, which is represented by this symbol. How to use logical operator to compose a new relational expression. For example, if we have x less than 3 and we have another relational expression y not equal, for example, 7, then we can say and between them. Now we have a new relational expression, x less than 3 and y not equal 7. Now the value of the new relational expression is based on the values of each one. This is what we call a truth table. For example, for and, both of them must be true in order to have the final relational expression true. For OR, at least one of them is true. This will make the new relational expression true. But if both of them are false, then the final relational expression is also false. For NOT, always it just inverse the relation. So not true, it will make it false. Not false, it will make it true. Let's have example with C++ to understand this those operators. For example, if I have integer x equal 3, integer y equal, let's say, 5, and then I have bool z, which is x less than 5 or less than 4, which in this case is true, and y is greater than 9, which is false. So it will be true and false. Of course, with and, that means the final expression is false. So if I print z, of course here the result will be 0, means false, 1 will mean true. So we got 0, which means false. That's because this is AND. But if you use OR, x is less than 4, which is true, or y is greater than 9, which is false. With OR, we said if at least one of them is true, then the final result will be true. So now we got 1. Now what if we have for example this one, x less than 4, which is in this case true, but we make it not, we make not. So now z, this is true, not true, z will be false, which is 0 indicates it's false. Okay, now what if we have a expression that composed of 3 parts, like this one? X is less than 5, y is less than 7, z is greater than 100, and x, y, z, those are the values for those 3 variables. So x is less than 5, this is true. Y is less than 7, also it's true. Z is greater than 100, this is false. So true, or true, and false. Now what do you think the output? True or true, it will result in true. True and false, now the output will be false. Let's see what's the value of A. We got 1, which means the final result is true. It's not false. Why? Well, because usually AND is evaluated first, then OR. So here, when it evaluated first, this is true and false. That means this expression will be false. False or true, we know with or at least one is enough to make the whole condition. So now it will be true or false. The final result will be true. So we have to take care of the priority, which operator has higher priority. Actually, with the logical operators, not has the most higher priority, then and finally or.